Now we are going to start with the protection systems. So now why do we need protection systems for power systems, right? So the first reason is the power system equipment, it is very expensive, okay, and if they are getting damaged in case of a fault, then it is going to be a loss. So this is the first reason, to protect the expensive power system equipment. And second is, obviously when there is a fault, the power will not be delivered correct, right? There will be a power outage. We don't want that, right? So protection system, it helps isolate the faulty network so that the other healthy networks, whatever are present, they are not affected. The power delivery through the healthy circuit is not affected, okay? So to reduce power outage, it is necessary to isolate the faulty network. As soon as possible. So these are the major functions of protection systems. Now the protection systems, they are designed for the protection of various equipments in various ways, right? Transformer protection is going to be different from transmission line protection, right? So in that way, the protection system, the design of protection system is actually very vast. But here we will discuss a basic setup so that you will get a basic understanding, okay? Here we have a setup. This is the generator. This entire equipment in the box is the protection system, okay? So from the generator, there is a protection system first, and from there is either a transmission line or a direct load you can take. So what is happening under normal operation? There is no fault anywhere. What is happening? This you can see here, it is a normally closed contact. NC is normally closed, okay? So this is a circuit breaker. It is normally closed under normal condition. So the current will flow without any problem. Now what will happen when a fault occurs? Let's say the fault has occurred at this point, okay? So when fault occurs, what will happen to the current? A huge amount of current will flow, right? Because it is essentially a short circuit. Now what will happen? This CT that is present here, it is called as the current transformer. Under normal working operations, it is not going to react, but when a huge amount of current flows, then by transformer action, this is a secondary of the CT, by transformer action there will be a current that is produced here, okay, and a current will flow in this circuit, okay, and here we have the relay coil. Now once the relay coil is energized, when current flows in this circuit, relay coil will be energized, okay, and once it is energized, it will attract this contact here, okay. This is normally open, so under normal operating conditions it will be open. When the relay coil is energized during the fault, this contact is going to be attracted towards the coil and it will now close this contact, okay. So once this contact is closed, here a current will flow because of the battery here. So now in the trip coil, the current will flow, okay. So trip coil also under normal working conditions, this is closed, right. Now once the trip coil is energized during fault, this normally closed contact, it is going to be attracted towards the trip coil and this is going to become open circuited, okay. This contact will no more be closed, okay. Now if you consider the main circuit, the current flow is actually going from here, but now this contact is open because of the fault, so no current will flow towards the fault, okay. So this is the basic setup that we have discussed. Here some important equipment that you can see here in protection system is the circuit breaker, okay. First one is the circuit breaker. Second, you have the trip circuit. This entire circuit that you have here, this is helping in tripping the circuit breaker, so it is the trip circuit. That is the second important component that you have. And next, what is the equipment that is actually identifying the current? It is the current transformer, right? So that is also one major equipment that is required in protection system. And also we have the relay coil, right? So these are some of the major components that we have in protection system, but remember we have only discussed the basic setup. Now there are a few important terms that you should know here. First one is the actuating quantity. So if you remember in the previous example, we had the main transmission line like this, and here we had the CT, right? And when there is a fault, current will flow in the CT and eventually in the relay coil, right? So here the actuating quantity is the current, right? Because of the current, the relay coil is getting activated. So sometimes it will be in the form of voltage, okay? So the actuating quantity can be the current or voltage that is fed to the relay so that it operates, okay? Next, the pickup level. Now under normal working condition, there is no current in the CT, right? But if the current exceeds a certain value, only then there will be a current in the CT, right? So that is the pickup level, the minimum value of actuating quantity above which the relay is going to operate. The minimum value of actuating quantity above which relay operates. Okay, so this is the pickup level. Next is the reset level. That means the relay will go back to its original state once the actuating quantity goes below a certain level. Okay, so the pickup level and reset level, they may not be the same. Okay, so the maximum value of actuating quantity below which relay comes back to original state. Okay, so these are some important terms. So now we have seen the basic setup of a protection system. We have also seen some important terms. Next, you need to know that the protection system, it has two groups. Okay, first one is the primary protection. The next one, you have a backup or secondary relay. Okay, so why do we have a secondary relay? First thing is, it will work in case the primary relay fails, right? It is slower to operate when compared to the primary, it is slower to operate. And another reason is, if the primary protection system, it is taken out for repair or maintenance, then this will work in place of the primary relay.